All right, second attempt. So we are starting this tutorial with this topic, which is what is AI and what it has to do with ethics. And AI ethics at this point has had so much attention that I don't think anybody actually wonders anymore, but we should always wonder whether what we do makes sense. So I will just very briefly talk about where AI, why it is in our opinion that AI raises concerns about ethics in this set of slides. And then in the next set of slides, I'm going to go through what are the topics of research that are in AI, and I will give pointers to the tutorials in IJKE and workshops that cover these points, because there's actually quite many. So the what is AI is a complex question. And right away, I have to give a disclaimer, because Luis was making fun of me for when I suggested that we should start with AI. We clearly do not have the answer of what AI is. AI is a complex question. Let me just move here these. There we are. AI is a complex question. And what is the definition of AI is also complex, clearly, because in order to define what artificial intelligence is, you have to have a clear understanding what intelligence is, and we don't claim that we have invented that. And what I'm going to talk about is what we do when we do AI, and how that specific approach to creating artificial intelligence leads to ethics concerns. Now, as I said, all definition there is not one great definition of AI. There are many definitions of AI, and all definitions of AI are wrong, of course, because they kind of cover something but not everything. But some of them are useful, and these two are useful for our goal here, to show how our approach to AI leads to AI ethics. And I'm going to show these two definitions. So per Pohl and Mackworth, all the references are on the webpage, so don't worry about that. Artificial intelligence, or AI, is the field that studies the synthesis and analysis of computational agents that act intelligently. And here, of course, an agent is an entity that acts in an environment, whereas a computational agent is an agent whose decisions about its actions can be explained in terms of computation. So very clearly, AI ethics is a topic in which there are many disciplines, and we have to be very clear as to what we mean when we use these general terms like agent. So an agent here is something that acts, and a computational agent is specifically a computational program, or the actions explained in terms of computation. Now, in contrast to this, there is another definition by Bellman from 1978, which has defined artificial intelligence as the automation of activities that we associate with human thinking, such as namely cognitive activities. Now you will see there is a big difference between these two definitions. I would say Bellman is the way we actually are developing artificial intelligence today. So we are taking cognitive activities in separation from each other, and we are studying them separately. For example, we study learning separately from knowledge representation separately. We study reasoning separately. We study multi-agent systems separately, interaction specifically, and so on. So even though our goal is to achieve some computational agency, perhaps the way we go about it is we do not directly create agents, right? We don't even directly create agency. We automate cognitive tasks in separation. And whether that eventually leads to an agent or not, I mean, okay, we would like it. Maybe some people would like it, some people would not. But the more important thing is that we want agency, right? Now, what is the problem when we are actually automating cognitive activities in separation one by one? This approach of automating cognitive activities in separation is actually something I think which we have taken from automation in general. Technology has been used to automate tasks for a long time. These here are two cute pictures of how automation of movement is executed. Now you can have automation without using intelligence at all. I mean, this is what automation has been for maybe a century now. I was very surprised to learn that the first autopilot was actually created in 1913. Right? No intelligence, no computer programming, nothing. So the way movement is specifically what I have in these pictures automated is that you take a complex movement, like I will do something with my hand, and then you decompose it into its basic actions. Then if you execute these basic actions in sequence, you get this complicated movement that you want to accomplish. This is how robotic arms are created. And then how capable this robotic arm is, you measure by checking how many of these basic movements the robot arm is capable of executing. And sometimes you need all 6 of them, but sometimes you just need 2 or 3, for example, right? And the thing is that we do the same with cognitive tasks, but the issue is, whereas we know that movement is decomposable, if I execute this atomic task in a specific order, what I get is the movement that I wanted to automate in the first place. We are not so sure that cognitive tasks are decomposable in the same way, that the cognitive task is somehow a linear sum of its parts. And but we definitely are not able to decompose cognitive tasks cleanly. We try anyway. So to illustrate as to what happens when you kind of splinter these cognitive tasks and automate them in isolation without having a clear understanding as to where you do the splintering, I picked one cognitive task, and let's see how AI goes about its automation. So the task I picked is reasoning. It's close to my area of expertise, but also reasoning is something that we really think about when we think about intelligence in a way. So reasoning is the process of connecting some phenomena with some other phenomena through some rules. So we are looking at causes and effects, and what are the rules that lead from certain causes to certain effects. And when we're talking about automating reasoning, there are typically 3 types of reasoning that we do, and that involve this process of using rules to connect cause and effect. So if we are given some facts and some rules, and we want to find answers that are entailed by these facts, then we are talking about deduction. So good old-fashioned AI focused on deduction. You can think Prolog. What entailments can you make? What can you know if you know a particular set of facts and particular sets of rules? If instead we are given some desired state of the world and some rules, and we want to know what has caused this state or how can we reach this state, how is this state possible, we need to use what is known as abductive reasoning. So abduction is sometimes not really seen as separate as deduction outside of logic circles, but the main difference is that whereas in deduction, if you have the facts and the rules, there are specific deductions that you can make, and that's it. In abduction, what you're actually most of the time talking about is narrowing down to the set of possible causes that can, when rules are applied, give you the effect that you're observing. Now, how we automate abduction, typically answer set programming is associated with the automation of abduction. And the third form of reasoning, let's say we have observed some phenomena, and we know that some of these phenomena is causing the other phenomena. Then we want to know how they are connected. So we are trying to find out what are the rules here, and then we talk about induction. So when we try to build these rules, find these rules that link cause and effect, we are talking about inductive reasoning. And this is what, how do we automate this? So this is what supervised machine learning and reinforcement learning are trying to accomplish, to find rules that link 2 phenomena together. So things that can go wrong because of this, what I call cognitive splintering, don't necessarily they're not necessarily things wrong in ethics. There are just mistakes in the reasoning. There are just inherent flaws of how we automate reasoning that can actually have an impact on ethics as well, but not necessarily do. But this is just to show that we do not really, this is the effect of doing reasoning in this way by splintering, right? So when we use deduction, what is very important to do here is that all the rules that are required are specified. So even the most obvious or the most common sense thing cannot be left forgotten. So it's very easy to have things forgotten. So consider this puzzle that I'm very it's one of my favorites. So it says you have to find out whether a married person is looking at an unmarried person, and you have the following facts: that George is looking at Jane, Jane is looking at Jack, George is married, Jack is not married. And now, in order to conclude, to deduce that a married person is indeed looking at an unmarried person, you can only do it if you take into consideration the common sense that a person is either married or unmarried, but not both, right? Now, it's very easy, and this is where it kind of touches upon ethics, I would say. It's very easy to forget this, to forget to encode this thing, and it's very easy to encode it using a particular approach to what marriage is, right? So you can say, at this point, somebody will say, well, a man is either married or unmarried, or a man is married if they are married to a woman, and so on, right? So you can build in these assumptions about the world here. At one point, you forgot them, you're putting them in, you have no bad intentions, but then you have a system that concludes that marriage is a union between a man and a woman, right? Which is not necessarily something that you want. In abduction, we have the situation that, again, as in deduction, it's very easy to omit the obvious, but here there is a second problem. So I will give you an illustration with a Sudoku puzzle, which I hope you are not going to try to solve right away, but trust me, the left puzzle is solvable and the right puzzle is not solvable. The left has only one combination of numbers you can put in there so that they create a solution, whereas the right has more than one combination. So in abduction, typically what you need to do is to, once you narrow down the possible causes, you need to devise a test in which you exclude some of these causes. So this is what Sherlock Holmes does very, very intuitively. Sherlock Holmes typically does abduction, and when he narrows down his suspects, looking for what caused the murder, then he asks, sets traps and asks follow-up questions, right? A machine cannot do that. So a machine can, at best, just narrow down the choices that you have, and then somebody else has to figure out a way to exclude the options, the causes that are not really working here. And this has to be done when the system is built, if you want the abduction to always give you a unique cause. And in the case with induction, the way we automate induction actually is so that induction always discovers correlations between phenomena and never actually causation. And in order to actually further check these correlations, whether they are causations as well, what you have to do is run particular targeted experiments. But again, we do not, this is not automated, right? This is what people do and the machines can do. Of course, the problem with this is that there exists correlation between phenomena that absolutely have no causal link between them. So this is an example from the beautiful websites that collects these funny correlations to illustrate that correlation is not causation. Of course, there is the second problem with how we automate induction, and that is that your rules, the quality of your rules, whether of correlation or causation, depend heavily on which examples of causes and effects you have taken into consideration. And there is always the possibility that that rare example is right beyond your horizon that nullifies all of your correlations, but you did not have it in your data set. Now, if you have been paying attention, what you should be wondering is, what does reasoning not automate, and what happens, where do these causes and rules come from, and what happens after the deduction or abduction or correlations are being established. So if I zoom in of this reasoning picture, I will find that there is more to reasoning than reasoning. So in reasoning, we frame the problem very cleanly, but how do we get to this clean resolve problem to reason with? The answer is a lot of human labor at this point. So first of all, we need observations to encode all the elements of reasoning in a language that can be fed to a computer. Let me try to move my, there we are. So you need all of this. You need to observe what is important, what are the causes you are interested in. You need to, you need knowledge engineers or some kind of human experience to encode everything, to represent everything. You use knowledge representation, in fact, to figure out, which is a separate field, to figure out what representations are useful, make sense, efficient, and so on. And then, of course, on the other side, you also need someone to interpret the results and then possibly decode them back into human language, or enact in the case of when your causes and effects are actions, and what possible actions and what you need to do. But most importantly, you also, if you are using rules in your reasoning, then you need domain experts to establish what are the important rules, how do we capture them in the representation language, and how do we make sure that all the rules that we need are there. So in the past, all of these people were experts. In fact, AI solutions were aimed to be used by experts, which means that before I deploy my solution, I know exactly who are the people and what properties they have that will use my solution. Today, in fact, a lot of the work is being done by non-expert people. So the one thing that kind of pushed one of the things that pushed machine learning to the forefront is they did away with these very costly domain experts, and because you don't have rules there that need to be encoded. So what means that you can use people that don't have a particular expertise in a domain to observe and identify relevant and represent your examples. So classification of training sets is done by people who have time to do this, and you pay them actually very little to do this. But more importantly, the applications of AI are not necessarily only for experts, and they're not necessarily even done by experts. Anybody can download a neural network from the internet, from somewhere, from a repository, and a training set, and train the neural net with the set, and get some kind of a prediction system, or get some kind of an inference. And when I say anyone, that includes people that may not necessarily are aware that there is a very big difference between correlation and causation, and are using these predictions or rules that they find as correlation rules as causation rules, where in reality they're causation rules. So why AI ethics? Because we build systems that interact with the world of people now, but these systems are not really agents, because they just automate some cognitive tasks or parts of cognitive tasks, but they do have some agency together with the people somehow that enact and help into this process. So how do we make sure that the sum of all parts has a neutral, if not positive, ethical impact in the end? How do we make sure that everything that needs to be thought about has been thought about and encoded in the system? So at the end of this part, I would like to bring your attention to something. Whenever we say AI ethics, or specifically whenever we say machine ethics, and I haven't yet told you what that is, people keep thinking about the driverless car and the trolley problem. So what should the driverless car do? The brakes are failing, the driverless car decides by itself, should it run into pedestrians, or should it run into an embankment and destroy the people that are in the car? This is from the Moral Machines project. And if you are the only person on earth that hasn't tried it out, I encourage you to go ahead and play around with these examples. The important thing here is what I want to tell you is that this is not our problem in AI ethics, okay? It is not about the trolley problem dilemma or hard moral dilemmas, but this is our problem. So everywhere around the world, there is a place where you can go and get your cheap coffee fix in the morning. And it's typically a machine, at least I think everywhere in Europe, where you walk up and you kind of pay at the till, and then walk up and choose your own coffee. Now we are unfortunately under a pandemic, and there is a strong motivation to not have such machines that everybody touches with their fingers, and then the machine can be a vector of infection. So you may want to replace this touch system with a voice-activated system, where you come to the machine and say, coffee black, no sugar, no cream, for example, right? So should we do this? This is our problem. Why? Because in order to, what you would do when you replace a voice input with tactile input here, is that you replace something that was done by machines to something that is now done by a human in a way. And there is a very large asymmetry between people understanding how these voice-activated machines work and how they and what they do. In order for the machine to be able to react to your command, it has to passively listen to the sounds of the environment, and whenever it hears the machine or coffee or something, activate itself. But when it does that, it creates a lot of data, and this data is stored somewhere, and then it is being used by someone, right? And how is it stored, how it is used? This is a public space in which a lot of people come, and previously in this public space, there were no hot microphones, and all of a sudden there are hot microphones. So how does that change the interaction between the people? So you change a lot of things in society by doing this very simple task. I'm not saying it shouldn't be done, but you need to be able, you need to understand that it brings some kind of an ethical impact on the environment. Okay, so this is the end of the first part of my slides, and this is a good opportunity to ask questions. I'm not sure how the question system is supposed to work, but yeah. I am staring blindly at the screen. Oops, something happened. Okay, I see nothing.
Anything in chat? I don't know if we get.
Maybe people are jumping up and down in Gather Town and say, I have a question, I have a question. Okay, well, that's good. That's good in the sense that what I said can be considered controversial by some people, and they would very much love to argue with me, and I would have enjoyed that at the conference, but apparently here it doesn't happen. So some. Okay, anyways, don't be shy about questions. I will move on to the second part before I leave you into the hands of Louise, and that is the landscape of AI ethics. So let us begin with a definition, which is a bit more concrete than what AI is. That is, what is AI ethics? So AI ethics is a subfield of AI that has emerged in the past decade and is concerned with the problem of how to have AI in our society ethically. So how can we make sure that when we research, innovate with, deploy, apply artificial intelligence, the ethical footprint of that is not negative. And then there are, I would say, two ways to go about this, answering this question and tackling this question. The first way is to make sure there is no negative ethical impact on society when introducing the AI into society. And the second way is to observe that moral reasoning, so reasoning about making decisions. Sorry, that somebody wanted to say something. Okay, maybe not. Reasoning about making decisions is itself a cognitive task, and we can automate the cognitive task. So we can have AI in our society ethically by making AI able to do ethical reasoning. And this automation of moral reasoning is machine ethics, and this is what this tutorial actually is about. However, there is very much overlap between all kinds of concepts and topics and so on. So in this part, we give you the landscape of AI ethics bar machine ethics. What do we talk about when we talk about AI ethics? As of today, there are more than 20 books under a skeptical count that are devoted to AI ethics. DBLP, which is, I believe everybody here knows, the Computer Science Bibliography Service, indexes more than 4,000 publications on some topic of ethics or morality and computer science. Of course, in the title, one cannot really search the abstracts of DBLP so easily. There have been several new journals, workshops, and conferences that are devoted to AI ethics. There are several tutorials here. There are several workshops that are devoted to AI ethics. There is more than 150 AI ethics guidelines proposed by countries or companies that work with AI. These people, they have crowdsourced a collection of more than 200 courses on ethics and technology. The authors then studied 615 of the syllabi that they have collected in this way to see what people are actually teaching and who is teaching ethics for technology students. And they observe a high frequency of topics such as law, policy, privacy, surveillance, inequality, justice, human rights, social and environmental impact. But if you look at the topics, there is no like 100 topics and this is a narrowing down of the 1%. It's basically, the conclusion is it's all over the place. These guys, Hagendorf and, oh, I'm clicking on the wrong place, Hagendorf and Jacobin and al. They studied specifically the ethical guidelines and to see what people are actually guidelining there. Explicitly, sorry, it's Jobin, not Jacobin, Jobin and all, they observe a convergence around the ethical principles of transparency, justice, fairness, non-maleficence, responsibility, and privacy. So why am I giving you the grand tour of who publishes where and what in AI ethics? The reason for this is that there is very much not a consensus on what exactly the topics of AI ethics are. This is a problem because there are papers on AI ethics all over the place in all kinds of venues, and it's actually very hard when you do research to actually find them all. But here, my point here is that there is no agreement. Now, if we look at just at the research on AI ethics that is done in computer science, in my opinion, there are, in addition to machine ethics, 7 subdisciplines in AI ethics that study different issues on ethical impact. And so these are typically, it's important to mention, also distinct from machine ethics because they focus not only on ethical impact in AI, but on computation in general. So these are explainability, accountability, transparency, responsible AI, privacy, and fairness and bias. So fairness and bias go together because fairness is sometimes defined as absence of bias. So in the next one slide on each of these, what do they mean and how are they covered? Where do you start if you want to read more about them? So let's start with accountability. Accountability in general is a relationship between an actor and a forum in which the in which the actor has an obligation to explain and to justify his or her conduct to the forum, and then the forum can pose questions and has the power to pass judgment and correct the behavior of the agent. And the actor may face consequences. The forum can impose consequences on the actor. Now, when what the actor is explaining and justifying is not his or her own conduct, but the conduct of an algorithm, then we are talking about algorithmic accountability. This quote is from a paper, and I will link that in the webpage. I keep forgetting to do this. But if you want to read more about algorithmic accountability, there's a beautiful paper out there, which is What to Account for When Accounting for Algorithms, a Systematic Literature Review on Algorithmic Accountability by Marianne Wieringa, and I point you to that from FAT from last year. So the next concept that we have here is transparency. Transparency can be defined as the availability of information about an actor, allowing other actors, namely the forum, to monitor the workings or performance of this actor. So let me just position there we are. So transparency is the availability of information about an actor, in this case, availability of information about the algorithm, allowing other actors, the forum, to monitor the working or performance of this algorithm. In other words, transparency is about information related both to outcomes and procedures used by an actor, this one, and it's relational, involving the exchange of information between this actor and the forum, right? So if you want to do more on transparency, then the starting point, I would say, is the article called Transparency by Nicholas Diakopoulos in the Oxford Handbook of Ethics of AI, which also does not really help you map the landscape very neatly on what AI ethics is, but it's a useful book nonetheless. Right, so the next concept I would say is explainability, and this is how we what we study to make sure that in the future, when the cars do everything by themselves, we kind of are in touch as what do they do. Sorry, it's okay, let's say. So of course this is a joke. I couldn't resist by including, but not to include this little cartoon. Explainability is perhaps one of the oldest disciplines of AI ethics. It was the term explainable AI actually comes from a DARPA project from 2017. The explainable AI program of DARPA was defined as follows. It aims to create a suite of machine learning techniques that produce more explainable models while maintaining a high level of learning performance, which in this case means prediction accuracy, and enable human users to understand, appropriately trust, and effectively manage the emerging generation of artificial intelligence partners. Now, it started as a question that was specific to machine learning, specifically because there was a concern, there is still a concern that the way neural networks connect use their training data and give classifications is not transparent, and it is not easy to explain how does a change in this in the data set lead to a particular change in a classification, right? But now explainability is a more general problem of all complex computation, and even per DARPA. So now DARPA defines explainable AI to be AI systems that can explain their rationale to a human user, characterize their strengths and weaknesses, and convey an understanding of how they will behave in the future operations. If you want to get like a very narrow, very point-on overview of what is happening in this field, then there is this article, again, I think it's from last year, DARPA's Explainable Artificial Intelligence Program by David Gunning and David Aha. There is more to explainability than computer science. So explainability is really about automatically creating this account in the accountability relationship. So the relationship is about an actor giving an account to a forum. So how do we automatically create this account? This is what the explainability field is studying. And here there are a lot of questions as to how, what is explainable? What does it mean for something to be explainable, to which target group, and so on. But in computer science specifically, we're looking specifically at how do you automatically generate the account. Explainability can be accomplished, as per today, in one of three ways. And not all of these three ways are available for all types of algorithms, of course. First, explainability can be considered a design feature of an algorithm. So basically, this is explainability by transparency. You make the algorithm in such a way that anybody can actually look at the algorithm and see what is happening, right? The second approach is explainability by backtracking, where you accomplish explainability by an algorithm that backtracks its own work to extract justifications or reasons to each decision it takes. And lastly, explainability can be accomplished by a second algorithm. So you explain algorithm A by building algorithm B that creates basically interpretations of the decisions that are made by algorithm A, and it is algorithm A that is your subject to the account in the accountability relationship. Now, HK hosts the longest running event perhaps in algorithmic explainability. This is the XAI workshop. And the link to the workshop is in the below in the footer here. I have noticed that there is also a tutorial called Logic-Enabled Verification and Explanation of ML Models. So I expect this will give a lot more detail on explainability in machine ML models specifically. And we talk about verification in this tutorial as well. So you're all set to follow this other tutorial. The next topic that we encounter in AI ethics, this is responsible AI. So responsible AI is concerned with ensuring that the forum, this guy, has power over the actor to make sure that compliance happens. So to make sure that the actor does give account, and that the actor in the forum can have the power to impose sanctions on the actor for non-compliance. Now, responsible AI is perhaps the most diverse and complicated subfield, and there are so many things going on here from so many different disciplines, and it is very, very difficult to put them all together. So I have decided to actually give you a link to the set of slides I have prepared for my students from the spring semester of 2020, where there is a lot of references on these slides on topics in responsible AI and works and what do people actually do there and so on. It's still very narrow and very limited source, but it's more than this slide. If you would rather read a book, then you can do worse than reading Responsible Artificial Intelligence by Virginia Dignam. And I believe I encountered also this tutorial in this conference, AI Ethics in Multi-Agent Systems. Now, it could be that this tutorial is about responsible AI, or it could touch upon some the topic that I would hope have time to talk about at the end of the tutorial, which is the role that social choice plays in AI ethics. I'm looking forward to it. We'll see what it is about. All right, so algorithmic accountability has as a goal to ensure that an algorithm specifies certain desirable properties as set out by the form. There are two properties that are explicitly given a lot of attention in AI ethics today, and those properties are fairness and privacy, and specifically fairness is a very hot topic at this moment. So this is this illustration over the algorithm is my way to illustrate fairness of an algorithm so badly. Fairness of an algorithm is basically the concern that the algorithm works more or less the same for more or less all of the people that are using it or come in contact with it. Now, fairness in AI is a very large topic in machine learning, and I think Luis will discuss as to, or was this in the open questions? Maybe we will also discuss as to how little there is talk about fairness in machine ethics, and this is an open question as well. But I don't want to talk too much about that because there is a tutorial that is specifically on fairness here at HK, Fair AI in a nutshell. Can algorithms be fair? So we can follow that tutorial for a much more detailed and targeted introduction on fairness. But if you don't have the time to the tutorial and you just want to read the paper, then the one paper that presents what's going on in fairness in ML, I found it recently and it's very nice. It's called A Snapshot of the Frontiers of Fairness in Machine Learning, and it is by Alexandra Choldechova, I never pronounce her name properly, sorry, and Aaron Roth. Right, and the last topic here, and also another property that we would want an algorithm to have, that is fairness. That is privacy. And so here the concern is that we want that the algorithm in its operation does not unintentionally or even intentionally reveal the impact negatively on the privacy of the people who are involved in it. So who are involved in different phases, like who contribute the data that is used in the algorithm or who are then using the algorithm. So this image here is a meme. I think it's from a Moroccan TV. It kind of perfectly illustrates as to what happens when algorithms are not really behaving well in terms of privacy. You're trying to anonymize the data on one end, but not paying attention that on the other end, the anonymization does not really work and it breaks down and it actually reveals everything about the data that you want to anonymize. When privacy is also out there with responsible AI, perhaps in terms of how complex this topic is and how poorly defined some things in it are. So what is algorithmic privacy in terms of AI ethics is a completely different question than what is privacy in terms of computational security, where this term has a very specific meaning and nice definitions. When we talk about privacy in AI ethics, people typically talk about a thing called differential privacy, but then there are papers everywhere. And if somebody is interested in doing some good work, then a systematic review of what privacy is in AI ethics would be very welcomed and warmly cited everywhere. So, sorry, this was a difference between privacy as a value and privacy in cryptography. And so for differential privacy specifically, if you just want a tourist overview of it, then I have found that chapter 1 or 2 of the ethical algorithm book by Kearns and Roth actually does a very good job at explaining what differential privacy is. So I'll point you in that direction. All right, so this is the landscape of AI ethics that is not machine ethics. So now we are going to talk about what is machine ethics itself. Oops, that was clicked too fast. What is machine ethics? I will stop recording so the video doesn't get too long, but we do questions and Luis.